Today in class, we completed task 8.8, Rainy Day, which was a practice understanding task where we revisited some of the features of functions in standard and factored form. We solidified our understanding of factoring by connecting our work on factoring trinomial expressions to factoring in standard form, and we practiced solving quadratic equations in different forms. In the Ready section, you're being asked to interpret the quadratic expressions and functions. In this example, we're given the following function, which represents a ball being thrown vertically upward at an initial velocity of v sub o in feet per second and rises a distance of d feet in t seconds. We know that the first term, the constant, represents the initial height. That's the height at which the ball started. The velocity is the rate at which the ball is traveling. The t being the time in seconds. And the coefficient to the last term, the negative 16, that's the acceleration due to gravity. If we know that the ball rose a distance of 20 feet in 2 seconds, we can take that information and replace our distance, d of t, and our t's with the values 20 and 2, as shown below. We can then solve to figure out what the velocity was, or what the rate was that it traveled. In this example, we can see the function written in standard form, in factored form, and in vertex form. Vertex form you'll focus on in Math 2, but at this point we have spent quite a bit of time working with both standard and factored form. We can use the different forms depending on which feature it is that we're trying to interpret or identify. Different forms will make different features easier to identify. For instance, if we're looking for the x-intercepts, the factored form would be ideal. If we're looking for the minimum or maximum, whether it's going to have a minimum or maximum, the standard form would be more helpful. If we're looking for the y-intercept, again, the standard form would be the most helpful. In the set section, you're going to be analyzing and practicing projectile motion problems similar to the problems that we did in class today. You're going to want to use technology for this, either the Desmos calculator or your graphing calculator. You'll want to set the parameters for your y-axis as shown in this video. When we input the function into our calculator or into Desmos, we can obtain lots of the features of the function. For instance, you can see here that we can clearly identify the vertex. In this case, it's a maximum, and which is located at the point 4,800. We can also identify the x-intercepts, which are located at 0, 0, and 8, 0. We can also see that when y is 600, in this case we're talking about the height, so that's the distance or the height. So at a distance of 600, that would occur, the x value representing time, at 2 minutes as well as at 6 minutes. So we can see that that's happening twice in this function. You can see it in the graph on the right and in the equation on the left. In the blue oval on the left side of your screen, you'll see the little gear. If you press that gear, it will convert the equation into a table. with that table of values, you can see the different points on your function on the graph. In the Go section, we're going to be solving word problems that involve quadratics. So these are real-world applications of quadratics. In the example in the video, we're starting with a rectangular vacant lot, which is going to be turned into a community vegetable garden. The vegetable garden is going to have a uniform path around it, meaning that the path is going to extend out from the vegetable garden on all four sides equally. They give you the area of the lot represented in with a trinomial equation, and they tell you that the width of the path is X meters wide. And that's going to be the same coming out from all four sides of the vegetable garden. So we're going to start with our equation. And as always, the first thing we're going to look for is there a greatest common factor among the three terms of the trinomial? And we notice right away that 4 is the greatest common factor of 4x squared, 40x, and negative 44. So when we factor that 4 out, we're left with 4 times x squared plus 10x minus 11, and all of that equals 0. The next thing we're going to do is factor our trinomial, which will result in 2 linear factors, x plus 11 and x minus 1. We're going to solve for x using the zero product property. So we're setting each of the factors, each of the linear factors equal to 0, and using inverse operations, we will get our two values for x. Now, in the context of the problem, it doesn't make sense for negative 11 to be the width of the path around the edge of the vegetable garden, because we know that distance cannot be negative. So the only reasonable solution to this problem would be x equals 1, meaning that the width of the path is 1 meter, and that's extending out from each side of the rectangular garden.